this, right? Okay, that's a traditional wave. The term for that is a transverse wave. That's a typical wave, that's what we're used to. And for that complete cycle to occur, you're going from the beginning of one wave to the beginning of the next wave for a complete cycle. Okay? It's got to have all the up and all the down, so we get a complete cycle. Okay? Make sense? That length, if we were to actually take a look at the length, it's called the wavelength. Okay? From here to here. That's the wavelength. And it's given this variable, this symbol, lambda.
So, can you say that, can it be said that wavelength is equal to cycles? Or can you not just do it like that?
It's kind of like wavelength is the amount or the distance a wave is able to travel in one period. Kind of like that. It's the length that happens in a single period. And, or you can say the period is the amount of time for one wavelength to pass. It's probably the easier way to think of it. But that's kind of, as far as thinking of the transverse wave and wavelength and all that, this is another variable you're going to need. Okay? The main equation for waves is that the velocity of a wave is going to equal the frequency times the wavelength. Because basically what that's saying is, think about the variables we just saw. Wavelength, it's a length, so what's it going to be measured in? Meters. Frequency. Hertz. And I said the other way of thinking about that is a 1 per second, right? Cycle per second. Okay? So, if you have this times that, then you end up with meters over seconds. Guess what that's a unit for? If I said something was going 8 meters per second, what are you thinking? Speed. Or velocity, distance divided by time. So this equation is telling us that we can get the velocity of the wave. Now, here's the key thing. The velocity of a wave, or another key principle, velocity is determined by, it's not equal to, but I'm writing it this way, it's determined by the medium it travels from. Okay? The medium determines that. The medium, and I'm not talking about a size, medium I'm talking about is what the stuff is made of. So you and I are sitting here in this room and we're talking. What's the wave of my voice, the sound wave, traveling through? Air. So it's because of the air that we could determine the speed of the sound. And it turns out, remember when we were talking about heat? As stuff heats up, what happens to particles? They move faster. Okay? So, do you think those faster moving particles may have an impact on the ability of sound to travel through them? Absolutely. The closeness and the sparseness of those particles makes a difference. If they're really close together, it works better. Think about dominoes, because what a wave is energy. If I were to put a stack of dominoes here and line them out, and I tap one, this domino does not end up down here, but the energy of one hitting another, hitting another, hitting another makes the difference. And that's kind of what happens with a wave, and the energy in a wave, is that the energy of a wave moves from one particle to the next, to the next, to the next, to the next, and the closer those things are, the easier it is to transfer that. Does that make sense? So a solid, it travels faster and easier than like a gas. Yeah, Javi?
So would a wave move faster, like here in Midland, than it would, and like on top of Mount Everest?
Because the air is more dense?
Because the air is denser there?
Yes.
It wouldn't be like noticeable out to the ear, but technically speaking.
Yeah. The density of the air, the moisture of the air, the temperature of the air, all of that makes a difference. And so there's kind of a weird play upon that as well when you start looking at it overall. Yes, sir, Tim? Okay, perfect. 253. Okay. We're going to shift gears here in just a second. I'm going to show you something else. But yeah, all that makes a difference. It makes a very big difference in determining what the medium, how the medium is affecting it. But, yes, in fact, and that's kind of how we, in Midland, we depend upon this with geologists, because they can take and look at the ground to see the speed is of the wave coming back and determine what type of substance we have. The medium that it's traveling through.
Oh, it tells
And
them.
lo and behold, maybe there's oil and maybe there's not.
Oh, okay, that makes sense.
Okay?
That's a good one. You got it. That's good.
Yeah? Okay. All right. Okay, we're going to stop there for the moment, okay? And I'm going to shift gears. I want you to get down a couple of websites.